Hello, my name is Ian Sierra and this is the Lab 2 video report. The purpose of this lab is mainly the same as Lab 1, where we wanted to see the remaining amount of charge left on a piece of clear tape by charging two pieces of tape with the same charge. But we want to evaluate the charge across the entire piece of tape. This experiment uses the concepts of electric force, electric field and interactions, electric field superpositions, and the electric field of distributed charges, which includes Coulomb's law and the electric field equation like the last layer. However, we will use a differential form of the electric field equation to account for distributed charges. The gravitational force equation was used as well. These equations were used in the computational model to calculate the electric force and gravitational force. Review from Lab 1. The first step was to identify the charges of the pieces of U-tape. I first stuck them to a base tape, ripped them off, and evaluated their interactions with each other. The U-tapes repelled from each other. Then I evaluated the interactions between a plastic pen with a negative charge and the U-tape, and they were attracted to each other, indicating that the U-tapes were positively charged. Next, I had to evaluate the excess charge on the tape by seeing if I could get the top U-tape to float by placing the bottom U-tape underneath it. Due to room conditions, I was not able to get the tape to float after trying many times in different locations. There are some assumptions made from Lab 1 that remained and others that were removed to account for the differences between the labs. Assumptions that were made for Lab 2 were the net Y component of the force on the top tape is 0. We had to ignore air resistance on a moving object and assume that each U-tape made had about the same amount of charge evenly distributed along the length of the tape. Now to the calculations. The first calculation for the magnitude of the gravitational force from Lab 1 was the same calculation for Lab 2. The next calculation was for finding the charge on the tape, treating the tape as a point charge. This value of Q was our initial estimated net charge. Finding the number of electrons on the tape and finding the fraction of atoms that gave up electrons were a part of the Lab 1 calculations. The highlighted values of mass, distance, and charge are data points that were used in the computational model. Now on to the computational model. The first values I had to add to the code were the calculated mass and the estimated net charge. The net charge was changed from the value found in the calculations to a new value to make sure the electric force and gravitational force were equal. I created a function for the electric field that would be calculated at each of the point charges. The top and bottom tapes are defined by line charge functions that create small spheres to represent each charge. The position of the top tape was changed to the distance between the two pieces of tape, and there are 10 point charges. Then we move on to the four statements that iterate through each of the point charges in both pieces of tape to find the electric fields and electric forces. Arrows for the electric fields are created during the iterations. This is where the differential form of the electric field equation comes into place. All of the electric forces at the point charges are summed to get the net electric force on the top tape. Arrows are then created for the electric force and gravitational force. When we run the code, you can see the red spheres represent the top tape, the blue spheres represent the bottom tape, the green arrows pointing up in different directions represent the electric field at each point charge, the white arrow pointing up represents the net electric force, and the yellow arrow pointing down represents the gravitational force. Now on to the conclusion. When comparing the estimated values for the charge using the point charge model versus the line charge model, the line charge model value is larger than the point charge model value. The difference between these two values is 1.242 times 10 to the negative 8. The two values for the charge Q are different because the effects of the gravitational force are different when considering a point charge versus a line charge. A point charge just has to worry about the y direction, while line charges consider locations that are not directly above the center of the bottom tape. The line charge value of Q is closer to the real value because it takes into account the charge being distributed along the length of the tape, which is the more realistic situation than the charge being at one location on the piece of tape. Thank you.